In today's data-driven world, efficient data retrieval is paramount. Large datasets require intelligent strategies to access information quickly. This is where database indexes come into play, acting as signposts that guide us to the desired data swiftly. Just as an index in a book helps us locate specific information quickly, database indexes speed up data retrieval. Imagine searching for a specific product in a massive online store. Without an index, the database would have to scan every single product, leading to slow and inefficient searches. Indexes solve this problem by creating a structured pathway to the data. They allow databases to pinpoint the required information rapidly, saving valuable time and resources. Indexes are crucial for optimizing database performance, particularly when dealing with substantial datasets. By understanding how to create, manage, and utilize indexes effectively, we unlock the true potential of our databases, enabling rapid data retrieval and analysis. In essence, a database index is a data structure that improves the speed of data retrieval operations on a table. It achieves this by creating an additional lookup table that maps key values to their corresponding rows in the actual data table. This lookup table is sorted, allowing the database to perform efficient searches. Imagine you have a table of millions of customer records. Searching for a specific customer by name without an index would require scanning the entire table, row by row. However, with an index on the customer name column, the database can quickly locate the relevant rows using the sorted lookup table. Indexes are particularly beneficial for queries that involve filtering, sorting, or joining data based on specific columns. By pre-sorting the data in the index, the database can avoid expensive operations like full table scans, significantly reducing query execution time. The true power of indexes lies in their ability to accelerate data retrieval significantly. When a query uses an indexed column, the database can quickly navigate to the relevant data subset using the index. This targeted approach minimizes the amount of data that needs to be scanned, leading to faster query responses. Consider a scenario where you need to analyze sales data for a particular product category over the past year. Without an index on the product category column, the database would have to examine every single sales record. However, an index allows the database to swiftly isolate the relevant sales records, enabling rapid analysis. Indexes are especially crucial in online transaction processing, OLTP systems, where rapid response times are essential for a seamless user experience. By strategically indexing frequently queried columns, we can ensure that our applications remain responsive even under heavy load. Creating an index is typically a straightforward process involving a simple SQL command. The syntax may vary slightly depending on the database system being used, but the underlying concept remains the same. We specify the table and columns to be indexed, along with the type of index to create. For example, to create a B-tree index, a common type on the customer_name column of a table called customers, we would use a command similar to create index, customer_name_IDX on customers, customer_name. This tells the database to create an index named customer_name_IDX on the specified column. Managing indexes involves monitoring their performance and making adjustments as needed. Factors to consider include the size of the index, the frequency of data modifications, and the types of queries being executed. Regular maintenance ensures that indexes remain optimized for optimal database performance. Selecting the appropriate index type is crucial for maximizing query performance. Different index structures have varying strengths and weaknesses, making them suitable for particular use cases. Two commonly used index types are B-tree indexes and hash indexes. B-tree indexes are versatile and widely supported, well suited for range queries, sorting, and comparisons. They excel in scenarios where queries involve operators like greater than, less than, or between. Hash indexes, on the other hand, are optimized for equality comparisons, making them ideal for key-value lookups. Choosing the right index involves analyzing the types of queries being executed and understanding the underlying data distribution. By selecting the most appropriate index type, we can further enhance query performance and optimize database efficiency. In conclusion, indexes are indispensable tools for anyone working with databases. They play a pivotal role in accelerating data retrieval, making it possible to extract insights from large datasets quickly and efficiently. By understanding how indexes work and how to utilize them effectively, we unlock the true potential of our data. Just as a well-organized library relies on a comprehensive index to locate books quickly, efficient data management hinges on the strategic use of database indexes. By indexing frequently queried columns, we empower our databases to retrieve information rapidly, enabling data-driven decision-making and analysis. As data continues to grow in volume and complexity, the importance of indexes will only continue to increase. By mastering the art of indexing, we equip ourselves with the knowledge and skills to navigate the ever-expanding world of data with speed and precision.